Warm greetings from D. Mary Rose Mala, Assistant Professor in Mathematics, St.Joseph's College for Women, Tirupur. My e-content is entitled as Introductory Concepts of Fluids and Types of Flows. My e-content comprises of introductory concepts of fluids, types of fluids, and types of flows. In the introductory concepts of fluids, we will see what is fluid dynamics, what is a fluid, what are the various forces which are acting on a fluid. Fluid dynamics is a branch of science which deals with the study of motion of fluids or bodies which are in contact with a fluid. We will define what do we mean by a fluid. So any material which flows is a fluid. For example, water flows, kerosene flows, paint flows. These are all examples of fluids. Two types of forces act on the surface of a fluid body, namely normal force and tangential force. A force which acts along the normal direction to the elementary surface of the fluid is called as a normal force. A force which acts in a tangential direction to the elementary surface is called as a tangential force. Two types of forces act on a fluid body: body force and surface force. A body force is one in which we apply a force externally on the surface of a fluid, but the influence of the force will be felt throughout the interior of the fluid body. Say for example, if we place a nail or an iron rod on a magnet, the iron rod and the nail gets magnetized. So this is example for a body force. In the case of a surface force, we apply a force on the surface of the fluid, but the influence of the fluid will not be felt throughout the interior of the fluid body. When we boil water in a container, we can see droplets of water on the inner surface of the container. So this is an example of surface force. Stress. Stress is force acting per unit area. It is classified into two types: tangential stress and normal stress. There are four types of fluids: compressible, incompressible fluids, viscous and inviscid fluids. In the first container, we can see a liquid. When we apply a pressure on this liquid, the density of the liquid will never change. All liquids are incompressible fluids. And in the second container, we can see that a gas is being filled in the container. When we apply a pressure on this container, we can see that the gas gets compressed and the density of the gas changes. So any fluid which exerts this property is called as a compressible fluid. In the case of a viscous fluid, the motion of the fluid will not be rapid due to the presence of friction in the fluid particles, and viscous fluids exerts tangential stress as well as normal stress. For example, honey, castor oil flow very slowly. In the second diagram, we can see a bottle of water is flowing very rapidly. This is an example of an inviscid fluid. In the case of an inviscid fluid, only normal stress is exerted on the fluid. We can see a stickiness in the case of a viscous fluid. This viscous fluid is also called as a real fluid. Inviscid fluids will not be sticky in nature. Inviscid fluids are also called as ideal fluids. We will see the various types of flows. So before getting into the concept of flow, we will see what do we mean by deformation. So deformation is a physical process in which there will be a change in the shape and size of an object when an force is applied on the object. If we see a droplet of water on a table, it will not flow. But if we produce a jerk to this table, we can see that the water flows and gradually its shape and size changes. So this is called as a flow. So we will define what is a flow. If the deformation increases continuously under the action of forces, the property is said to be a flow. There are various types of flows: laminar flow, turbulent flow, steady flow, unsteady flow, irrotational flow, rotational flow, uniform flow and non-uniform flow. In the first video, we see that the fluid particles flow parallel to one another. They form a definite shape, and the fluid particles do not intersect with one another. Such a type of flow is called as a laminar flow. In the case of a turbulent flow, the fluid particles intersect with one another and thereby we do not get a definite shape. Such a flow is called as a turbulent flow. When we light a cigarette, initially we can see that the flow follows a laminar flow, and as it goes up, it follows a turbulent flow. A flow exerts properties such as pressure, density, temperature, volume, etc. If these properties are independent of time, then the flow is said to be a steady flow. So over here, the flow does not vary with time. In the case of an unsteady flow, the properties are dependent of time. So the flow varies with respect to time. Example, tidal waves or flood waves. Rotational flow. So in a rotational flow, the fluid particles rotate about their own axis. In the first diagram, we can see a fluid flow which is circulatory in nature. In the case of an irrotational flow, the fluid particles will not rotate about their own axis. Next, we will see what is a uniform flow and a non-uniform flow. In a uniform flow, the fluid particles will cover equal distances with equal velocities at each section of the pipe. So over here, velocity is independent of the distance. But in the case of a non-uniform flow, the flow will not cover equal distances with equal velocities at each section of the pipe. So over here, velocity is dependent on the distance. In this e-content, I have covered a few basic concepts of fluids, various types of fluids and types of flows. Thank you.